Hello and welcome, fellow Mythrunians. Without further ado, let's go ahead and get started. This week we'll be looking at more cave generation. So before we get started, let's thank the patrons. You guys are the team that's making the dream work. All right, and so we'll go ahead and get started. We're going to do in cave generation. Pretty much exactly where we left off last week, which was I had the point influencers working, which are these round guys, the spherical shapes that, we had 3 of them in a row there, kind of making a pseudo cave kind of deal. And so today we'll work on the line versions of those, and it's too bad the thing's not updating. So we'll work on the line versions. Let me go ahead and open up the whiteboard again so we can keep track of what we're doing. Create a new board. Okay. So as you recall, like if we pretend these blocks themselves are Mythruna blocks, and you drew a point here, or you have a point here, then anything within a certain distance, we consider not a block, not a block, not a block. Hey Ron, how's it going? And so next what we'll do, I think, can I just, yeah, I can just undo. Next what we'll do is the line version, which is like this, and then, within a certain distance of this, we'll do similar. We'll consider those, empty space. So we'll carve out the empty space, any distance with that line. So it's similar to the point version, except for we've got to do point to line segment checks. So let's go ahead and get that started. All right. Kill that because we have to restart it each time. All right, now last time we based the point influencer on the river section, and we'll do the same for the line influencer because it's actually closer to a river section than it was to the point influencer was. The line, and if we have time, we'll do the one that's used for canyons as well, which is I think I called it a wall influencer before. It's basically, for canyons, instead of doing this in 3D, which is what the line influencer will do, we'll do it in 2D to figure out the range, and then we'll use the line height, in the like this is X and Y, or X and Z, and Y is into the screen here. We'll use kind of like if this is higher than this, we'll slope it so that, anyways, from a side view, if this is the line, then we carve out a certain distance above and a certain distance below, or we carve right at the line, and then between that and the roundness, it makes these, carves out like a canyon, a chasm. And of course, if you string a bunch of them together, then it makes the rough surface and so on. Anyway, all right, so let's turn, what did I call it? Cave. That's original. Okay, so carve a tunnel into the world. Got to replace all of this with, it's been a few days since I've gotten to actually write code, so this will be nice. I did put a video out earlier of the progress I've made on the dungeon generator, so you guys should check that out if you haven't seen it yet. Say point influencer had inner radius, outer radius. We will have the same thing here. We will have a start and an end. We won't have a depth. We don't need any of this stuff. So we should be able to let's steal all of this because I'm a cut and paste coder from way back, as y'all know. And then I'll replace this point at the start. 3 end. I did it and then I did it. Undid it. Okay. Okay. And is it okay for those to be vec3i? Yeah. I think it's okay for the caves because of how they work. But one thing I found out about the rivers, and I ended up redoing it all, was the river started out with a radius. And because everything is int, that meant that I couldn't have a river that was only 3 wide, for example, because the radius was either 1 or 2, and a radius of 1 was a river that was 2 wide, and so on and so forth. Or I couldn't, anyway, there was some river widths I couldn't get, so I changed it to width, and then I divide by 2 and use a double. But for caves, I don't think it's going to be necessary because we're never going to have a cave that thin. So we should be able to get rid of these, replace them with this, and get affected columns becomes very similar to the river. I don't think I kept any of the comments from the other, did I? I did, actually. Huh. Okay. Oh, I can leave this comment in too. Cave sections. Yep, so bounding box should be fine. I mean, technically I could be smarter about it, but this works. All this needs to be, in fact, probably anywhere I have influence, I could change to outer radius. If I spell radius correctly. Yeah, just replace all, it's fine. Yeah, that's going to be wrong, but that's okay. Alright, so get the affected columns. And this, again, Mythruna the column is a 32 by 32 vertical section of the world. Bigger than a Minecraft chunk. Okay, so this calculates all that. Are we inside? Yes, we're inside. Probably still need clamp and all those guys. Smooth step. No. No, I don't think we need mix either, but that's okay. Alright, intersects. I think this is actually okay, yep, because we already did the outer radius bit. Yep, it's just smarter code than the above. Okay, we technically don't need get distance squared, it's not part of the API, but we can implement it, and to do that we would need, so we can go ahead and say in subtract start. Where's the distance? Yeah, but this is distance in XZ. What did I use that for? Well, you know what? I'm going to just not include it because it's not part of the interface. I'll go back and implement that later if I need it. And I think what we did with the point influencers, I ignored the morph for now. Yeah, so we'll ignore morph for now. But I don't know if you guys noticed in the point example, you know, there was some dirt hovering in space, and by doing the tile morph I can actually take care of that, because the way the rivers worked is a a river would carve itself into the two-dimensional tiles that are used for the far terrain, and those tiles are what are used to render the chunks, so to speak, to get the initial depth of the river, and then it morphs it beyond that. And I think we'll probably do the same thing for the caves, because we need to be able to carve out anything that breaches the surface will need to be carved out of the far terrain as well. And once we have that, we'll have already pre-filtered any thin little bits that would have floated above it. At least that's the plan. But I'm not going to implement that today. All of this, as long as I take out the 2D bits, because we don't need that. And this can actually be, again, end, subtract, start. Is that what I did up here? Or I decided I didn't need to. Or that was the method I got rid of. Okay, so end, I start to vec 3D. And yep, so we normalize that to get the direction vector. If you don't know, line segment distance, basically given 2 points, you can find the normalized direction, which is the direction that's unit length, and then whatever point you have out here, you can do a dot product between these two vectors, and it'll tell you where on this line, basically the length down the line that this would project onto if this was a right angle. And so from that you can find out where the closest point on this line is, and then get the distance between these two guys, and then you know how far away this point is from that line in any dimension. But we're looking at 3 dimensions, but it works in 12 dimensions if you needed 12 dimensions. So it's kind of a cool trick. And point influencer, I think only modified. The other thing is, at some point I have to go back and actually I don't need any of this stuff. I don't need any of that. Somebody have to go back and modify this to deal with water. That's a complicated problem on its own. Start, subtract origin. So this puts start in our local space. Local space being the tile or the column itself. Basically, we're figuring out our relative position to whatever tile we happen to be in, or this one in this case if we were using anyway, whatever column. Okay, we don't want to zero out y because we're doing this in real 3D space. Radius is radius. Radius is as radius does. And since we probably will just want cannot type tonight, which is really unfortunate. Okay. So okay, so this is a similar issue to what we had before. And this is going to be calculating it in 2 dimensions, because we are trying to first see if this is even is something we have to deal with, because maybe we're too far away. Maybe like this block over here is nothing in here will be close enough to do that. So if we already know or no, it's within here, right? Within the one we're doing, this XY, XZ here is already too far away from the cave, so we don't even need to bother to calculate the rest, and we can skip it. We don't have to do the Y direction yet. If I talk too fast and you guys want to ask a question, please feel free. Otherwise, I'm just going to keep chugging along, because it's only 15 minutes in, and I feel like we're making progress. So, all right, so we clamp the length. don't think we're going to put round ends on everything. So unlike the river, we don't need to worry about that. And project, but this is only project in 2D space. Yeah, so we actually did need dir xz. Yeah, so this is, we're going to need to do both because of what I just described. So here's a tip, right? I'm doing repetitive calculations, and I could have done, I could have allocated both of these together, then calculated both of them together, and so on and so forth. But by doing it this way, I make sure that I converted all of my dir xz's over. You don't always have you may not always be in an environment that has an IDE to help you with that stuff. But so if I had accidentally left one of these as a dir, it would yell at me about it because I hadn't defined dir yet. Dir. Okay, so dir, these are xz. And we clamp 0 rel. We're doing an xz space. We're good. Dir xz. We multiply by the projection, which is that thing I was talking about where we did the dot product, and so we know how far along that line segment we are. And so we know our point in 2D space. And so if that distance is less than or equal to, actually if we can do even better than that, if the distance squared is greater than outer radius squared, we're done. We don't do anything. In 2D space, just from a top view, excuse me, we're not in range, so we don't even have to bother to check further. And now we can do a proper projection because we know that we need at least the 3D point that we project along. So we will go ahead and get, we don't have a Y yet. Oh, so we can't do that yet, right? So that's the thing, is because knowing the radius isn't important. We're going to be iterating over Y anyway, just like we did over here. And so we can calculate the sort of min and max by knowing where along. So we can calculate so the minimum Y is going to be in 2D space, wherever we are along here. The Y that would have been there plus outer radius is the max Y, minus outer radius is the min Y. So if, from this guy, if we looked at it from the side, maybe it's looks like that, and we're at this point here. We need to calculate. So this is let's say this is x, and this is x, and this is, so up here is y, right? So the outer radius here and the outer radius here, because we're going to be iterating over this whole column anyway. So we'll just need to know what the min and max is, so we don't bother looking. The world is tall, and this is going to be a relatively short section of it. We don't have to worry about that. But we do need to calculate then the point along the regular dir multiplied by the projection down our 2D line. So that gets our point in 3D space. Yeah, cool. That's no more complicated. Okay, minus outer radius y max equals p dot y plus outer radius. Oops. And when we get to, this is going to be more important when we get to roughness and stuff, but okay, and so then I think we can just steal the code from point influencer, because it's doing the same thing. There is a way to calculate the math. Yeah, see, we did the exact same thing. There is a way to calculate the math again to know exactly where the y is to start and stop. If we're looking at this from the front view, we know here and here, but we also know how far out this way we are, and there is technically math that could tell us where we are on the circle, you know, or maybe we're here, and what the exact min max y is, but it's more math than I want to get into here, and it doesn't actually matter. It's only a small performance improvement because we'll save some time iterating over things that we're just going to skip anyway. But here we are going to calculate the actual distance to our point, and yes, so we know y. We already had x. Yeah, so see, it's not that bad. We have to do, this is the only other calculation we have to do extra for each one of those y values. It's not that big a deal, and we already have outer radius squared, so we even saved a multiplication there. No, I got rid of that, didn't I? Oh, I'm in the wrong stupid class. Yeah, so I think I copied that over here already. No, I was going to. I got lost explaining things. One thing at a time, one thing at a time. Okay. So y equals, why were we nested double deep? Oh, because I didn't do the early bail. Mostly I like to do loops like this where I bail early so that I keep the indent low. So this can be simplified to outer radius squared, which is an optimization I did already this time. Whoops. Okay, so that should be it to do a line influence. I gotta get rid of this junk code that I left behind, and then fix the, oh, actually that's correct. Okay, so assuming I don't have any compilers, which is super unlikely, we ought to be able to add this to our little test. So instead of these 2 points, let's add, okay, I'm going to do 2 separate lists for the moment because I don't want to really, there's a super interface that's going to be a regular influencer interface that allow us to put all this in one place, but I'm going to keep them separate for now just because it makes the code simpler. So let's make a new align influencer that goes from center to center.add, let's say 40. So it'll be in 2D space right now, or just flat. And we'll make it a little narrower. Okay, and so then, see, this is why I had that get distance, I think. Anyway, we'll just do the same thing for, again, this would have been better if I had made a super interface. Yeah, so we'll do new vec3i influencer.getEnd. Alright, doesn't matter. Get start. .min local .getEnd. So that should give us the so we get the, make a new vec3i with the start in it, and then we do min local, whichever is min for the xyz will end up in min, and then we'll do the same thing for max, except for instead of min local we'll say max local, and then to each of those we will add local outer radius, or radius, yep, we already got it. 0 radius, because this is in 2D space that we're worried about this, because it's for deciding whether this intersects a particular tile, which is 2D. All that's good. So if we do all that and our min and our max intersect the tiles min and max, we're good. Okay. So that's all good. That's all good. That's all good. And then we do this bit for line influencer because we're designing on the fly. And it didn't make an interface yet. Okay, so intersects line. If that's true, add the morphology, and that should be it. Let's check it. See if it'll compile first. Of course not. I've already made results. I thought I got rid of the extra one. Oh, but I pulled it back again. All right, and so, oh, yeah. I did these as double. They don't need to be, shouldn't be. But P is a double. What did I do over here? Oh, because P wasn't a double here. Point wasn't a double here. So these can be. Now we'll make sure we're as low as the lowest can go and as high as the highest can go. For all of you don't know what floor does, given a decimal like 1.23, floor will take you to the next lowest whole number, and ceiling will do the opposite, will take you to the next highest whole number. And then they'll still return doubles, but we need ints. And so that way, if we were a little bit above a value on the top, y will include that in a little more, and min will include that in a little less. So that's good. We always fully contain the blocks. All that's good. Cannot find symbol local point because there is no local point. We calculated the actual point in 3D space. We're good. Okay. Hey, we got 6 concurrent viewers. Hello, everyone. If YouTube is not lying to me, we've got a pretty lively crew tonight that are lurkers. You guys are waiting to see something real, right? Okay, so let's go ahead and run the world generator and see if we actually see our cave. Anybody taking bets? Whether I've got something messed up? I should have put some logging in that line just to see if we see it execute. Howdy, Adrian. I hope everyone had a good week. My week was eventful. I did did a bunch of work on the dungeon generator. Yeah, so see, we didn't get. It didn't do nothing. So now we get to debug. But I worked on the dungeon generator and I put that video out that you guys may have seen. So this is all intuitive. Well, sorry about that. It is to me because I've done this a bunch of times. Of course, it didn't work, so I could have just been making up everything. Let's see if it's even running. I like to suspect that people who know this kind of coding well might understand more about what I'm talking about. And I breeze over a lot of the math, but if you guys ever are curious to learn more about that, let me know. Even if I don't talk about it in here, I can do separate explainer videos where I can do some animation to show some better done charts than the hand-drawn ones to kind of show what the math is doing. Maybe explain it a little better. I definitely plan to do that for the dungeon generation at some point. It'll happen faster if people ask for it, but I think the algorithm I use is a little unique, so I think it'd be fun to make a video about it. A video more straightforward and with better diagrams than the ones I kind of hacked together during the live stream, 3 or 4 weeks ago. Okay, so did we see? Yeah, we saw a line influencer do its thing. Make sure we're not. So that'll be the easier way to see anyway. Okay, so we did see line influencer run, which means we can do. So step 1 would be to P and mark the distance, because we've got a small. Nice thing about the small example here is that we can P3D. We can do things like this because I know it's not going to run 1,000 times, maybe only a couple hundred times, and so since we've got a little isolated test environment. And incidentally, to take the thumbnail for this video, because we're modifying the real world code, that means every world right now at this particular location will carve this very value out, these caves out. So I loaded the game and I warped to this location and took a picture of Fade standing inside the big crater. That was the thumbnail for this video. Okay, so okay. In day job, I've been using Linux for development, and it's fun because it's fun because, like, if I scroll back like this, even though the build is still going and it's still running, I can let it go and it's not going to instantly. It's going to snap me back. If I want that here, I have to pretend like I'm going to mark something if I want to go look at stuff. Yeah, so all these are really huge, so that makes me think. Yeah, see, and we kept going for the rest of the column. And why are we repeating ourselves? Point is the same over and over and over and over and over and over and over. Like you see, we've got all of these that are essentially the same. We're not advancing. Oh, because that's the nearest, because whatever we're looking at, this is still the nearest point. But it still seems wrong. We're gonna need more. We're gonna need more debugging, kids. So let's say XZ, we want that too. Leads to that. And all of those, of course, it's like way too far away. Local start, subtract origin. I've done something dumb, I just haven't spotted it yet. What is length? Length is the 3D length, so this needs to actually be length XZ. That's not what's wrong, because the lengths in this case should be the same. So that's the thing, is if anytime I look at, oh, am I using the wrong direction vector? Because we made the tunnel flat, the 2D version and the 3D version are identical. Yeah, but we never, of course, we never passed this, which meant we're potentially not even looking at. Actually, what I could do is move this down to here, and then, so this is within the tile. This is what our origin is. And we subtract the end from the start to get our direction, that's all fine. Subtract the end from start to get our direction, that's fine. Then we start to subtract from origin. Yeah, because we want that in world space. Do we never convert it to local? At rivers again. So this one never gets a local origin. Maybe we don't need a local origin. Yeah, why do I have one? Did I get that from point influencer? Yeah, that's what I did. So do we even use this for anything important? No. So we don't need it. Because everything we do is relative to... we're doing everything in 3D space. We don't really care. Except... these guys, how do we do this in the river? Because this is true there as well. Because we're constantly tracking local start. Yeah, I did over here though, didn't I? X minus local start, yeah. Okay, yeah, so we're good. We're just in local start space, calculating our point in local start space. That's fine. Yeah. That all works. What I mean is, we've got different coordinate spaces, right? We've got the world, the tile coordinate space, the big, 1024 by 1024, and so sometimes we do calculations relative to its origin. I'm drawing the world upside down. Actually, XZ space works this way, by the way. And we've got the coordinates relative to, some column, right? And so a lot of times you spend, 0, 1, 2, 3, 4 in this space. And we don't have to worry about that here because the start is here. Whatever block we happen to be doing, even if it's in a different column, we'd be subtracting it relative to this guy. And so we're just getting all these vectors. We don't care about this. We don't care about this. As long as... as long as this is in the same space as our line, we're good. So that's I was just double checking all that, and that's all good. Of course, famous last words are when I finally figure out what the problem is, and it is related to that, and I can come back and eat my words. But anyway, come on. The only sad part is it does take a bit. It does take a minute to generate. Alright, that's the end of the Pepsi. Okay. I didn't fix anything, but let's just double check. Yep, nothing's fixed. I talk about how I do dumb things. And Let me make sure I didn't do something really dumb here. Oh no, I made it way big. So we should definitely be seeing cave. I was worried I had made the thing too short and it was just being subsumed in the 20 units of point influencer, but that's not true. We should be outside the sphere by quite a bit. Okay, so let's see what's going on here in this, so you can kind of see what's happening. So we've all got huge distances. X, Y. C. Am I showing the right thing? Yeah, but I don't want just X and Z. I want XRel and ZRel. And why is P not moving at all? And why is P 0? Which means local start was 0. Are we exactly on an origin? That doesn't seem right. So this is calculating the, column data origin. So we are in column space. What I said before was wrong. We are in column space. Yeah, so what we do is we take the starting point of the line and we move it into column space by subtracting the origin of the column. So we move it into this space, and that way any of these other points are also in that same space. And we should be okay. And what I really want to do is some some of that in here. Okay. And then we run our test again. We will learn things. I'm going to go ahead and chew a piece of gum. I don't know if it's going to come through on the thing. If you guys hear me chewing and it's annoying, let me know. I always wonder, I sometimes do it on morning teleconferences, and I wonder if anybody can hear. Look at all that data. Let's just stop it. Okay, so local start. Okay. But P doesn't move. Trying to think. This is a way big number. And if XREL is 24 and ZREL is 0, P is 0 and 0. At best we should be 24 squared away, and I don't think 24 squared is anywhere near 18,000. I mean, I can check. No, so there's something wrong in our distance calculation. Or the projection. Okay, so let's just, I was already marked. So what I do sometimes now is take some of the data and drop it in so I can look at it with the code. You know, same thing a debugger would do, you know, in nice little fancy windows and things, but I find a large percentage of the time the debugger changes the thing I'm testing to the point where I don't get good data. So I'm going to be logging anyway, so I just use that. Okay, so we know what P is, and we know what X, Y are, so C, oh, because P still has the Y in it, we didn't zero it out. So P dot Y equals 0. Because we're doing that part in 2D space, we don't want the 3D element, and so putting this back for a second, what we were doing, you know, given this example in our tile, so see if I can get all this on the screen at the same time. Okay, so let's say you know, here's our column. We've got our cave that stretches out this way. We're going through each of these blocks, X, you know, X and Y, X and Z. So X is 0, Z is 0, right? XREL is 24, you know, which means that the start is actually back here somewhere. And so, yes, it's true that, you know, for whatever reason, the X of the line is 0. That's the closest point, let's say. It just happens to be right on our origin as well. But ignore that for a second. And so we want the distance between these two guys, but we want it in 2D space, just XZ space, and we were getting this 135, so we were getting, you know, 24 squared plus 135 squared, and that's what this is probably. So let's see. Plus, oh wait, memory set, clear, 135 squared. Yep, and then plus memory recall equals, well, we're somewhere in the ballpark, right? That's sort of what's going on. Oh, because, you know, this is just XZ, yeah, so we wouldn't have even had the 24 in there. So it would have been whatever I want to subtract it back out. Yep, look, that's exactly that's exactly the number. So that's what's going on. I didn't clear out the Y component, which I've just done here. And so we were doing a partially 3D calculation. That's not what we want, for all the reasons already stated. So once again, let me know if you guys can hear me chewing this gum. I definitely can hear it in my own ears, so. I picked up this habit somewhere along the way to drink less soda, and that's that after every can I drink, I chew a piece of gum, because I can make a piece of gum last for another hour or so. And so rather than drinking, you know, 8 or 9, still didn't work. Rather than drinking 8 or 9 or so sodas in a day, you know, I reduce my consumption to 3 or 4, or even less, sometimes 2 or 3. And it's all for the best. But anyway, now every time I finish a Pepsi, I want to eat a piece of gum. So we didn't still... Yeah, okay, thanks. So let's see what's going on now. We're definitely getting in the ballpark. We've got... Oh, see, we did get a 3D point come through. But it might not have... Let's see. Oops. Oops. I think it's funny, IntelliJ, the... Oh, okay. I'm almost done chewing this one anyway, so... I hope to finish this. I really wanted to get further along. I'm disappointed that I've been dealing with this bug for 20 minutes. Yeah, so this one definitely should have hit, as should all of these. We can put it right here. Okay. Technically, we wouldn't have even been in the right ballpark if that hadn't been a little right. It's bound to be something else dumb. It's bound to be something related to 2D versus 3D space and or, you know, coordinate systems, because those are always the bugs that I tend to find myself making over and over again. But let's see. Okay. Outer radius 36. Oh! Yeah. Our radius is really tiny. I mean, relatively speaking to the numbers we're talking about. Because we're thinking line distance, right? So the 3D point is, so the X-Men, we definitely should have carved something out in one of these cases. What I don't know is, okay, we do get some more. But they're all the same. Yeah, they will be because we're flat. So 3D point 16135. 3D point 16135, 16135, 161. So it's like we're beyond the end. Gosh, there's just something dumb I've done. Because every single point is, every single P is the same. For those of you who are better at math and have followed along with what I'm doing and are shouting at the screen right now, I apologize. Yeah, so let's look at the math again. Okay. Back to first principles. XREL is the difference between our current block coordinate and our local start, which is the start of the line in our, you know, leaf info space. So how do we get numbers Let me get a xrel as big as 41. Okay, because we cross many columns. That's fine. And so what I'm going to do, split this onto its own line, because I want to see what... Let's see what project was. No, first of all, that's wrong. But I mean, they'll be the same as I talked about before. Yeah, so P 16, 16, 16, 16, 16. Let's see, even... See, these are all in the same X, which is why they never move. X18, because our line is just along the x-axis. Okay, so rel goes up. Point is still the same. What was X start? We should have that up here somewhere. Oh, come on, I got like 2 minutes to have an aha moment that fixes the problem. Too much data. Oh wait, there it goes. Okay. So our local start, minus 24, 135. And so 0, 0. And it's right on the 0. So we put ourselves right on a line, essentially, one of the grid lines. It's kind of convenient. All right, x equals 0, z equals 0. We're good. So xrel is 24. And so, yeah, because we're 24 away. But then why didn't we project further along? Yeah, I need to see what the project values are. I suspect they're not correct. All right, chewing has stopped. Even if it's not annoying for you guys, I have big over-ear headphones on, and the chewing, I can hear it reverberating through my whole skull. Alright, so let's see. Alright, let's go. I should have added a big line to one of these. Okay, so let's look at this start, because we should be in the range. Oh, we're right on the border. Local start, 32. Yeah, so we're really far away in that case. I'll go back and look at the one I was looking at before. Well, I could alter the test a bit. Let's Yeah, we definitely should be seeing something. So what if I, let's verify an assumption. Center, so if I take this and divide it by 32, is it 0? No, it's 1008. So why are we on? What I'm thinking is, if we look at these, let's find one that has the local start. And before I run it again, I'm going to add a big, yeah. I've just got too much data for the scroll back now, but somewhere in here. Yeah. So I've actually added too much data for the scroll back, but what I was seeing is that local start had a z of 0, which doesn't make any sense. Let's just make sure. And what we'll do is we'll add a big old line here so we'll see the stuff better. Gosh, this is like when you know, you have something on your face and you think that you have something on your face and everybody sees it and nobody's telling you anything about it, and I'm just sure that the bug is something really stupid and obvious that I'm going to feel really dumb when we find it. And there's probably at least one of you watching that might have noticed it already, kind of thing. So start. See, local start of 32. See, that doesn't make any sense. Because if we were, let me bring back my calculator for a second. So 32,288. 32,288 divided by 32 equals. Oh no, I was getting, no. This is right. I am right on a line, and that's making things, whoops. It's making things harder. Like I was talking about before, and then I just did the math wrong. I was not thinking straight. Our cave is right along one of these lines, and so that makes the calculations look weird. But we are actually on the line, so like our z never changes, and that's okay. But it's also a little weird. But it should make testing easier, in fact. But I think we have too much output right now to be of any utility. And because we know that, we can set less, yeah, z is less than 10, let's say. We can reduce our output to a range that we're interested. This is also something that's harder to do in a debugger. We already know that z will either be, anyway, we're interested in checking that tile that z is the 0, the top border of. And it's actually weird the case that it was, no, 32 makes sense. Yeah. So this case we should only see, you know, we should only be debugging if this is the column we should only be debugging, you know, the first 10 rows of Z. I should have started this while we were gone. Anyway, let's do this, start that. So we should end up with less debugging output, which should make it easier to spot the problem. Can't believe I've spent a half hour on this. Okay, so we saw some results up here. I need to mark where it's going to keep scrolling. There we go. So in this case, start is this. Yeah, so we're minus 24. Yeah, so already this should be, project is 24, distance is 0. This should be a 3D point we're interested in. But it's 0, 0. And that doesn't make any sense. Because local start, oh yeah, project 24, so 0, 0, yes. The closest point in that is our xy, yeah, our xz, because when z is 0, we are traversing right along the line. The question is, why aren't we carving that space out? So this is actually the exact case we need to test for. Yeah, so we can narrow this down even further by setting z equals 0. Okay, so we're going to check only when we're right along that line, and then we can add some debugging in here, because this is the guy that is not correct. Y min, Y max. Let's just double, let me sanity check some of these values. Y min, Y max should always be the same. Oh, we don't have any of the, anyway, we'll get a lot less output if we do it this way. So, if debug log info, so we can grab a little bit more yrel, d squared, and we can look up to see the outer radius, which should be good. And we set the cell to 0, which we know worked in the other code, so that's all fine. Something dumb, we're really getting close. It's got to be something stupid. The code looks right at first glance. Thanks for sticking with me on the journey. We go all bang our heads against the wall together. And okay, so we should get a lot less output this time. Yep. Yeah, see. Okay, so what do we got? Whoa, d squared is huge. That's not right. Okay, so we're only debugging when we're right on the line. And so if we're anywhere within the race, like the d squared should be small. Yeah, so xrel is 43 in this case. That's pretty big. We are outside. Why are we even checking then? Okay, so along the line. Project was 40, so we were beyond the end of the line, yeah. So why are we even in here? Okay, because we're only 3 away from there. Yeah, that's why. I don't know. That's weird. Anyway, let's go up to one that's where we know we should be drawing. Here, we know we should be. We should be right at 0, 0. Our line. D squared is 612. Wait, what? We're only projected 24 down our line. We are on the line. Outer radius is 36. So the 3dp is that. And then xrel is minus 6. Oh. Again, it is something stupid. And it is coordinate space. So let me show you. So, no, why is it? No, I'm wrong. It's got to be something like that. Local start is in column space. Yeah, because we got them in. Okay, let's go back up to our thing. Man, I'm sure I had it. Okay. See, because the YREL is small. XREL is 24. Oh. We don't care about this. We want to know the distance to the point. And so we need to recalculate. We recalculated. So this was the 2D. This is the point in 2xz space. This is the point in xyz space. And we need to calculate the distance from this y. Yeah, the YREL stuff is BS. That's wrong. So we calculate the distance from our 3D point to our block coordinate. And then if that is, yeah, we don't care about this YREL BS. That was for doing the dot product, and we're not doing a dot product anymore. We already, that was for XREL, like I was showing you down here. XREL and ZREL was, calculating this vector so we could find the projected point on the line. Once we know the projected point on the line, it doesn't matter whether we're doing it in 2D and 3D. We can project along the 2D line and find it in 2D space, or the 3D line and find it in 3D space. Once we have that line, we want the distance between these points. And I was calculating that up here for the 2D space. I was doing something bizarre that I copied from the point influencer because it worked over here. And actually it might be wrong here too. It just happens to be working. I'll have to examine that later. But anyway, this should fix the problem. And it was a coordinate space issue, right? Actually, well, it's just using the wrong, comparing the wrong 2 points. This should fix the problem. And if it had fixed the problem a half an hour ago, we could have been making cave systems. But, oh well. Maybe next time. We're only 15 minutes over, and some of you stuck around. God love you. Sticking around for the good fight. You just want to see a straight cave. Yeah, I was really hoping to get into the variation today. All right. So we should be good. Come on. Hurry up. If I move down here, can I see it? We won't be able to see it from here. Yep, there it goes. So we get a nice round cave. It's very dark. Yeah, so if I take, was it, oh, that's right, the first time, for some reason there's a bug that cropped up recently, that the first time you hit the, there's like, hit the spacebar to move into walk around mode, and hit spacebar to move out of it, and the first time you move out of it, it sends you back into where your camera was previously. It's supposed to leave you where you are. So we don't want the lanterns. We want magic white. It will cast more light. Oh, we want the big one because I had a small one. Yeah. So if we do this, we can do. Okay. So now we have our cave all lit up. This is, whoops, whoa. Okay, so now we've got a cave. It's boring because it doesn't have any kind of random variation. And it's normally the caves would not necessarily be this long on a single section anyway. But these are the primitives from which we will build cave systems. And then the wall influencer. I may actually implement the wall influencer on my own, since I get bogged down in debugging the math stuff, and we could get sort of into the inner and outer radius and so on and so forth. Yeah, that's the thing, is the smoother they are, the more they look like a lava tube. And so there's a random variation in the random variation that has to happen, because sometimes smooth caves are what you want. But anyway, I think this is where we'll stop, because I'm already 15 minutes over, or 20 minutes over. It's 15 minutes over. But we got the line caves working, and so from those you can see, like, well, real quick, let me, so we'll just say debug false so we won't get all that output. And I will move I'll move this down a little so we get like an angle. And I will make the cave slope down by a little bit. And so now we'll get like a cave that runs downhill. Okay, so. But yeah, so so I'll try to do the wall influencer on my own, because the math for that is actually even slightly trickier. It's closer to the river than this one. Slightly trickier. And then next time we'll work on making cave systems, that incorporate all three influencers, and work on the inner outer radius variance stuff. So that'll help. Basically, closer to the inner radius, the chance of a rock appearing is 0. Closer to the outer radius, chance of a rock appearing is 1. That sort of thing. So anyway, let's verify that. Yeah, so our cave went down. That's why we see the ground. So if I do this, it's going to do it again. That's okay. Yeah, so we'll fall while I should just do it right away twice, and then I won't have to do it or fix the bug. So let's put some light in here. Oh, it did it again. All right, let's select the light first. Magic white. Mini 2. All right. Okay, so we'll sit on the ground here, hit the space bar. Okay, good. Alright, so we've got a cave that slopes downhill and of course goes down farther and isn't at an angle. So angled caves work. They work across boundaries of things because we already knew we were right on the edge of a boundary, so we double tested things. So we can see a little better. So yeah, this is where I'm going to end it, and maybe this will be the screenshot for the next video. Alright, thanks for joining me, guys. Sorry again for spending an hour debugging a thing, but maybe that's interesting. I don't know. And let's see, where's the ops? There it goes. Okay, so thanks guys again. Teamwork makes the dream work, and you guys I consider you part of the team. Some of you contribute more than just monetarily. You stick around on these chats or these live streams, and some of you, a few of you actually contribute to the open source stuff, so that's good too. So thanks again for watching. Like, comment, subscribe. The subscribes mean a lot. I'm like at 830 or 880 or something. If I could get to 1,000 by the end of July, that would be really cool. The end of July is my birthday, by the way. So thanks again, and I will